And the instantaneous velocity, until I give you more tools to deal with them mathematically, which is coming in the next day or two, until I give you those tools, instantaneous velocity actually becomes a little bit convoluted to deal with. When you have a rate of change of position, i.e. a velocity that is itself changing, we talk about that in terms of acceleration, which we're going to talk about in more detail. Again, like I said, in the next couple days, we'll formally deal with acceleration. But if I have an accelerating object, the position is going to change at different rates, which means this thing is going to start to curve. A curved line on a position time graph means I have an object that is speeding up or slowing down. So I'm going to write that right below here. A curved line on a, I'm just going to say a PT graph. PT stands for position time. Means the object is speeding up or slowing down, depending on the direction of the curve. Slowing up, slowing down. And that depends on the direction of the curve. We'll analyze that on the bottom here in a sec. In order to find what my velocity is right now, using a graph like this, what we need to do on a curved line is use something called a tangent, which this is in the Physics 11 stuff because it used to be in Math 10. We'd look at circle geometry, and we talk about how a tangent line is a line that just touches a curve or a circle in exactly one spot and doesn't cross it twice and doesn't leave you with 2 points. But that's now all gone. So this is where I'm introducing you likely to the idea of having a tangent line for the very first time. So a tangent line is a line that just touches the curve at a single spot. I wrote that in here. Tangent line is a line that hits the curve at exactly one spot. And the job of the tangent line, I will write this here. The tangent line gives the slope of a single point on a curved line. Which is weird to think about how a single point in space can have a slope. Technically, a single point in space can't. But a single point that's part of a larger curve will have a slope. And these ideas here are where the mathematical field called calculus, this is where calculus was born, from these ideas here. So, James, are you in IB math? Are you in your pre-calc 12 though? You also taking calculus? Next year taking calculus. Okay, so but you're not taking it concurrently with pre-calc 12. You're studying on your own time. Okay, so no, you haven't touched it yet. Okay. Are there any other grade 12s in here who are also taking? Anyone here taking calculus? No, but next year. Okay, cool. This will come. Okay. So this, I'm not going to give you just so you're aware, there are 2 questions out of your homework that I'm going to get you to practice instantaneous velocity on. But the bulk of this, I'm going to put a big star here and a color that we can actually read. You're really going to practice this on an upcoming lab. And I want you to write that in here so that when we get to the lab and I say, okay, you're going to find tangent lines of this graph and it's going to give you such and such, you'll be like, what's a tangent line? I'm hoping by writing this down, you'll remember, oh yes, this little section that we talked about here, that's what I got to go back and do. So I'm really going to get you guys to practice this stuff using a lab that we've got coming up here in a little bit. Manuel, I see that hand. you can't have more than one tangent line because the tangent line hits at a single point. So every single point is going to have its own dedicated tangent line. So this point right there, I'll make it bigger so you can actually see it better. That point right there has a tangent that looks like this. The curved line doesn't have a single slope. A curved line has multiple slopes. Every point on a curved line has its own slope. So if you wanted to find, there is no such thing as the slope of a curved line. If you wanted to find all the slopes, you would need all of the tangent lines. And that would be a lot of work that I'm not going to ask you to do. On the lab, I'm going to ask you for 5 or 6. I can't remember exactly what the number is. And the curved line is going to be big, and it's going to be data that you've calculated. It's going to be great. Okay, so on a displacement or position time graph, if I give you a line like this, what's the velocity? How do you know?
Because it's not moving upward, and time is just continuing while the point stays still.
Time is continuing while the point is staying still. That's one way to look at it. The other way to look at it is from the mathematical ideas of slope. That's not rising or running, or it's running, but it's not rising or falling. So slope is 0, therefore velocity is also 0. Cool. What can you tell me about the velocity here?
Both of them are even, so while it's running and...
Well, you don't know what the scale is. You can't tell me that it's even until I give you a scale. This scale could go up. This could be 10 seconds, 20 seconds, 30 seconds, 40 seconds, and this displacement could be 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. What can you tell me about?
Slope is going to be positive.
Slope's going to be positive. So in this case, the velocity is positive. What does that mean? Yeah, Connor?
From its original position or the starting point, it is heading in a positive direction.
In a
So
positive
north or
direction, yes.
south,
Sorry?
If it was north or south, and we see north with positive, it'd be going north.
Right. So this tells you the velocity. We know the velocity is positive because the slope here is positive. Up to the right is positive slope. And then whatever the positive direction is, typically that'll be north or east or right or up. What else can you tell me about the slope? Or sorry, the velocity. It's constant. I don't know what the value is, but I know that the velocity is constant. It is steady. The number is not changing. And we know this because why? Because someone else said it here. I heard a woman's voice. It's a straight line. Was that Angelina? Yeah. Okay. How about this guy over here? Talk to me about what's happening here. Connor.
Similar to the line above the tangent line, it is moving, the speed is changing, and that's why there's a curve in the line.
It's more specific than changing. How is it changing? It's increasing. Because the line is getting steeper. As time progresses, steepness is being introduced, and so the velocity is increasing. And not only is it increasing, we also know the velocity is increasing and positive. Cool. Beneath it, we're going to draw 3 more. So draw me 3 more sets of axes. And then one of these graphs is going to look like this. One of them is going to look like this. One of them is going to look like this. You betcha. I would love nothing more. Talk to me about the velocity. And these are all, just so we're clear, these are all DT graphs. What's happening to the velocity in each one of these? Careful. In all 3 of them? Careful, 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 careful. I like the second thing. Was that you? Did you say something? It's negative. How do you know the velocity is negative?
It's like coming to a stop.
Do we know that? Is it coming to a stop? We don't know that it's coming to a stop, but we do know that in this case the velocity is negative. What does that mean? So v is, we know it's negative. How do we know it's negative? Yeah, because the graph is going on a position time graph. The graph is going going downwards in a negative direction. The slope is negative. So the velocity is negative. What does that mean? It's going, could be down, could be heading south. We're not talking about the slowing. We're talking about if a velocity is negative, that doesn't tell you if it's speeding up or slowing down. Negative velocity tells you it tells you the direction that it's moving. In this case, if it's negative, it's heading in a negative direction. This means it's moving in a negative direction. That's all that tells us. Now, if we look at the slope, we can talk about how it's moving. How is the slope acting on this line here? Yeah, Connor.
The speed is decreasing.
That's not what I asked. I asked what the slope was doing. Is the slope decreasing? What does a decreasing slope look like on a set of graphs? If the slope is decreasing?
It would look much like.
No, what does that mean? Don't point at pictures. Use
Okay,
words.
It starts up high on a graph or not.
Talk to me about slope, man. You're not talking to me about slope. When we talk about slope, if I don't give you values, there is one concept that you need to be thinking about when you think about slope. It also starts with an S. And then T. Steepness. Okay? If I don't give you values for slope, you have to think about steepness. What is happening to the steepness of this line? It's decreasing. It's increasing. It's getting steeper. As time goes on, it's getting steeper. So what's happening to the slope? It's not. That's what happens to the slope. The object, Manuel, is doing what you just suggested. But piece it together. As you travel this line, the line is getting steeper, which means the slope is getting, and so that value is going up, or well, the absolute value is going up. It's getting more negative. So what's happening to the velocity of our object? It's increasing in a negative direction. Yes. So it's moving in a negative direction and getting faster. Are you able to follow that reasoning? So why I really, really care about the language that we use here. And yeah, we still have a couple minutes till the first floor gets back, so let's keep going. What's happening here? Talk to me about this graph. Sure, Connor, go again.
The line is staying steady, so the slope is steady.
Slope is constant. Does that tell you about the velocity?
Velocity is staying the same.
Correct. Velocity is V is constant. And what?
It's heading in a negative direction.
It's heading. The object is heading in a negative direction, so that means the velocity itself is negative. Cool. So the object is moving in a negative direction. And, or I'll say it this way, at a constant velocity. Last one. If this is the line demonstrating the path of an object on a displacement time graph, what is happening here? Talk to me about the velocity first, and then we'll talk about the object. Manuel.
The velocity starts off in really fast and then
Okay, so you start with a large, so velocity starts large and I heard it.
decreases.
No, it starts large and sorry, no, talking. I'm stuck on the starting. The velocity is big and it's n. Starts with an n.
Negative.
It's negative. Okay, so at the very beginning, the velocity starts large and it's negative. It is negative. Okay, that just means you have a lot of velocity heading in a negative direction. What happens to the velocity over time?
It becomes steady.
It. Think about velocity is related to slope, and slope is related to the steepness of the graph. What's happening to the steepness of this graph?
Becomes
The steepness is going down, so that means the slope must be going
closer.
down. So that means the velocity is going what? Doing what, Connor?
Becoming more constant.
Not becoming more positive.
It's becoming neutral.
And in math, the number that represents neutrality is
Zero.
zero. Okay? It's not becoming more positive, it's becoming less negative, and those are different. Object, at no point does this line curve up. So it's not becoming positive, it's just becoming less steep to the point where it has no steepness. So that means your velocity is approaching zero. Is decreasing towards zero. To the point where at this point, is my object moving at all? No. So this is a little bit different. Like I'm talking with my math 9s right now. My pre-diploma 9s right now, we're talking about how, which number is bigger, -3 or -2? Well, -2 is bigger because it's greater. It's closer towards zero. But now we're thinking about, now that we're talking about physical objects and moving in space, some of that reasoning needs to be flipped around. And so I want you to slow down how you're thinking about this. The velocity is decreasing towards zero. It means the object is slowing down. Have a great lunch. I'll see you in 40 minutes. And I'll take up any questions you've got on this then. Be back by 12:20. We're going to keep going here. So instantaneous velocity, we're talking about velocity on position time graphs. Curved graphs mean things are speeding up or slowing down. So then we just analyze these last three down here. Were there questions about any of these things? Duo, welcome back. Procedure for thinking this through kind of makes sense. If you're stuck on any of these things, how I talked it through is how I would recommend you try thinking it through. Don't look at this and try and figure out what the object itself is doing. Think it through as a graph, and then at the very end, tie it all back together. So the graph here starts steep and gets shallower. What does that mean? It means the slope starts large, starts negative, and is decreasing. The slope on a position time graph represents the velocity of the object. So what's happening? The velocity starts big, it starts negative, and it slows down. So if it's big and negative and getting slower, that means it's still negative, but it's approaching zero. As the object slows down, its speed is ultimately going to reach zero. And a negative velocity just means that our object is traveling in a negative direction. So marching it through kind of step by step, piece by piece, is how I want you to go about thinking it through. Flip the page. There should be a big blank page. I want you to draw the following on the big blank page. So the top, basically third maybe just under half, is going to be a grid. Well, I'm not going to draw the grid, but a set of axes. This is going to be the position measured in meters. This is going to be the time measured in seconds. And we need some things. I need a one-dimensional path. Give me an example of a one-dimensional. When I say one-dimensional, I just mean like like a hallway, or just to keep us simple here. Sorry? Which hallway? Our hallway? Different? Third floor? First floor? Second floor hallway. Okay. So a second floor hallway. Where in the second floor hallway are we going to call 0?
At the rotunda.
The rotunda makes sense to be 0? Okay. So this we'll call the rotunda. And we're going to, what I want you to do is I want you to draw this. So put a dot right there. And we're going to draw this. It's going to curve up. It's going to do this. We're going to do this. We're going to do this. We're going to bring it down to a flat line there. Draw me something that looks like that. And I'm going to break some stuff up here. This is going to be A. This is going to be B. This right here is going to be point C. That's going to be point D. That's going to be point E. That right there is going to be point F, G. Okay, so we have our situation. This is a map, or not a map, but a depiction of the second floor hallway. And you have an object that does this. So what's going on? We got back. I still don't have Tanjo back. Or whatever else back. Yeah, Connor, talk to me.
Okay. From what I can tell, assuming rotunda is south of the position where we started.
The hallway actually runs east-west. So the rotunda is east of us. So this direction here, in this particular depiction of the graph, which direction would be positive? The hallway runs east-west. West is going to be positive.
Oh, okay. And then east is negative.
Because from the rotunda, the hallway goes west. So we're defining this way to be position west.
Okay. So
And we can't be at the end of the hallway, because if we're at the end of the hallway here, what does it mean to go this way?
it means time is continuing.
Sorry, what I'm suggesting is you can't go further west than the end of the hallway. So this position here can't be that end of the hallway. This has to be an intermediate classroom. So, or the stairwell perhaps, or something. Staff room maybe, I don't know. So what I want you to do, either alone or conversing with someone beside you, is I want you to put together a plausible story about what's happening here. And don't just say an object, like actually pick something, a second floor something. Because this is the second floor, that's the rotunda. This is west towards that end of the hall. Like, put me together a scenario where something does this. from between all of these timestamps. So this where it says A, B, C, D, E, F, G, H, or E, F, G rather, those are all different times down here. I don't know what those times are. I haven't labeled them numerically. Time A, time B, time C, time D, time E, time F, and then G is already on the line. I want you to put together a story of what's happening here. All the different pieces of the graph. Go! Either on your own or with somebody else. You can talk about it, absolutely. I still don't have Manuel back, do I? It should be a whole thing of website work, actually. It should be. If there isn't, then this one needs to go live over there. There used to be. Yeah, sure. Take one. I want you to draw that on that blank page there. And then write up your story. Write as well. Like actually put it down there. Pen to paper. Give me the story. What's happening? You got lost. I somehow doubt that, but okay. So Manuel, on the blank page, on the next, like, flip it forward, yeah, that guy there, draw me that graph, and then you're going to make a story. What's happening? What is an object? This is the graph representing the position of an object on the second floor hallway, right here, as time increases. And I want you to tell me what the object is. Positive is west, yes. Because this hallway runs east-west. West-south. What are you supposed to do? Write me a description using words of what an object that undergoes what? This position time graph.
I just have this worse something like
So it's like for 0 to A, like A is a time period. From 0 to A, whoever it is isn't moving. They're standing, sitting, whatever. They're static somewhere. And then something happens between A and B, and then B to C. C to D, something happens. D to E, something happens. What's the procedure there? What's happening? Jim? What's that? 2. That's all, okay? We start at the bench by T's room. Slowly walk to the front of the class. Where does it slowly walk to? You start, so this is the starting walking. And then what happens in front of the classroom? Where their class is. You need to return to the proper class. What the time E. Okay, so what's like where's all of the like what's happening all of this piece? Give me every chunk of time, what's happening? If it helps, it doesn't necessarily have to be a paragraph, guys. You can break it up. You can break it up by talking about it like this. We've got, from time 0 to A, this is what's happening. And then you've got A to B, B to C, C to D, D to E, E to F, and then F to G. From 0 to A is in class. Which class? Well, I mean, this is a physical hallway. What class? This is no. This is Kraus and Enns. Okay. Okay. Walking towards the end of the hall, B to C arrives at the end of the hallway, so stays. So that's for you. That's the end. Interesting. Stays seated. He stays at the end of the hall. So as you're approaching the end of the hall, I guess the B to C, that's the slowing down to stopping piece. DD quickly walks towards the water fountain. Drinks water. And then so there's a brief stop, and then starts off running towards the rotunda. F to G runs and arrives at the end of the rotunda. Works for me. Hello, ladies. What's going on? Mr. Minocha? Okay. Crosa? Who? Kraus? Arause. Okay, so a few of you guys are doing hands up if you're still working on yours, or are we ready to talk about it? A couple of you are still going. Hands up if you're ready to talk about it. Okay, so I've seen a few, and the ones I've seen, we've got we're getting an idea. Anyone want to share theirs that I haven't seen already? Sure, Connor. Was that kind of a hand, not a committal hand? Sure.
A student stays in the middle of the hallway or west of the rotunda, thinking he might have forgotten something.
Okay, so you have a student standing and thinking for the first chunk of time.
Yeah.
Works for me.
He starts moving forward gradually west.
Okay, so he starts, okay.
And
Accelerating west, speeding up west.
Goes faster, briefly, then slows down. Waiting a second and thinks again about where he might have left his wallet. He realizes he might have left his wallet that he left.
Okay, so he stands thinking, he speeds up, slows down, stops again, thinks about his wallet.
He realizes that it might be back by his classroom, so he suddenly runs quickly back east, point E.
Yeah.
Stops, but not for long. He gradually moves forward a little bit, realizing that there's nothing, that his wallet isn't there. And then quickly starts moving down, and then suddenly goes almost directly straight down in a break of a run east towards the rotunda.
Very fast toward, yep.
And then starts slowing down and towards the rotunda east, and starts slowing down and realizes he has to call his mom about his lost wallet. And so he sits down in an armchair and he has a
those armchairs. Okay.
and he stops.
Sad ending. You could have had him like seeing his wallet in the distance, so he slows down and then he picks it up and finds it. And
Yeah.
but no, now his wallet's gone.
Well, no, because
This is
I
sad.
figured you'd be heading to a class or something, so I was like, you probably.
Well, he could then, I don't know, maybe he sits in relief, and then what? Who knows what happens over here? But yeah, no, that's works. That's perfect.
Okay.
You got all the pieces. The standing, not moving. The moving west, speeding up, slowing down, stopping. The constant velocity the other way. The brief stop, and then the breaking into a run.
Yeah, with E,
Yeah.
I lifted mine slightly. If yours goes down instead of up, mine slightly goes up.
What do you mean?
Do you see how on yours it at point E
Yeah.
it banks down? I drew mine so it kind of almost went a little bit like a circle, so it kind of went up a little bit, had a little bit of a rise.
Oh, here you got a bump.
Yeah.
Okay.
Slightly, and then.
Okay, I gotcha.
Start banking.
Gotcha. Anybody else want to try? Like that's the idea of what I was getting you guys to look at. I looked at James and Brendan's before. It was good. Tristan's. I looked at yours. Yes, Khalil. Let's do it.
Okay, so zero to A, student is talking with friends in rest area across from the student outside.
Okay, so right under the TV there. Okay.
A, B, student and friends start walking west to end of the hall.
Okay.
B to C, student slow down. Student and friends slow down while walking. C to D, student and friends come to full stop while talking.
Okay.
D to E, student gets connects and faces culprit eastward left-hander.
They get what?
Connects.
Finessed. What does that mean? Someone. Okay.
And then E to F, culprit face out student.
The brief stop. Okay.
And then F to G, student catches culprit at the
Oh, so this is them catching. So the brief stop and then they start. Okay. Okay. Works for me. The only piece there that I might tweak is the this piece in here. I mean, you didn't really have much about like the running real fast and the slowing down to the catching. That's the only part I might add. But otherwise, it's great. We can go through a couple more if you guys like, but that's the idea. Getting all of these pieces in here, reflecting all of the stopping, the speeding up, the slowing down, the stopping, the constant velocity back the other way, the brief stop, the running, then to the slowing down the run to the stop, all while heading back towards the rotunda, is what I want you to be able to think your way through on a graph like this. Cool? Comments, questions, concerns? Yeah, Luis?
I just wanted to know, I'm going to do it, but I don't know like much about it, school structure to do it, and sorry about it. I'm new.
Okay.
So I was trying, but that's me.
I mean, if you want, all it would take is for you to go out and look in the hall and be like, okay, so I have a rough idea of where I am. Like, if this is, there's a few different ways. Someone said this, I think Tristan, you said that you called this the end of the hallway. James and Brendan, you called this position, was it someone's classroom? This was Prentice's room. This is the last classroom on the left. So the stairwell actually is a little bit further than this. So I didn't give you values. I didn't give you places. I just said this is where you start. You start somewhere in the hallway. It cannot be the end. So Luis, all you'd have to do is you go out and look in the hallway and be like, okay, well, it's about this long. There is where I'm going to call my start, and you guys can take it forward from there. So, but yeah, no, that's the idea of what we're looking at here. So what I want you to do now is I'm going to give you guys some time to practice this stuff. There's a bunch of questions in here, and you got about 20 minutes to do it. The one thing I want you to add is flip back here. I added a part C to this question 6. Question 6 uses this graph here. What I want you to try and do is, for 6, I want you to add C. Find velocity at 1 second, 11 seconds, and 13 seconds. And if you look, at 1 second, it's kind of curved. At 13 seconds, we're kind of curved. At 11 seconds, we're kind of curved. So I'm going to get at, for part 6C, these three things that I'm adding here. What I want you to do is I want you to use the idea of a tangent line and then finding the slope of that tangent line to give me what you figure the velocities are for that object at these 3 times on this graph. I'll go over how I would go through that tomorrow, but I want you to give this a shot. If you need to borrow a clear ruler, clear rulers make this a question like number 6 really quite nice. If you don't have a clear ruler at home, maybe start with question 6 and then do the other ones. And then I've got some extra practice here. These are all time, distance, velocity questions. So this is practice of the previous lesson that we did. And question 6, 7, and 8 here. 6 is to calculate the velocity of this automobile on each part of the trip. 7 wants you to draw a displacement time graph. And then 8 is just a slightly more difficult version of the DVT stuff. So on the front, actually I won't make you do all of these. I do want you to do practice one. Here's a how long, here is a how fast, and 3 is a how far. 4 and 5 are optional. You don't have to do those if you don't want to, but extra practice is never a bad thing. 6 and 7 and 8, though, I do want you to do. So just those 4 and 5 are optional. And then you've got some other stuff to take a look at here. Cool. This is all about analyzing graphs and then going back and doing some more of the practice. Now you've got 15 minutes to do it. On your market set giver, if you need a hand, let me know. I'm happy to assist. And feel free to work with the people around you. Naya. Yeah, you know when you got to leave and what you got to do. So do what you got to.